Welcome Clarity Coders. In today's video, we're going to cover Learn Python the Right Way, Chapter 3. Now this chapter is really important. We're going to start working with outside libraries and loops and visualize it as we're doing it. Now, as you know, if you're following along, you can check out the book version in the description below as well. And I want to thank Replit for sponsoring this video and bringing it to you ad-free. Let's not waste any more time and jump right in. All right, so as you know, if you've been following along, you don't have to do this in Replit. I'm going to, not just because they're sponsoring this video, but it's a really easy way for us to all be on the same page in the same environment. So if we work in Replit together, we're going to follow the same installation process for outside libraries. We're going to have none of the issues with different Python versions or anything like that. So this is the environment that I recommend you following these videos with, just for ease of use. But if you're following in some other version or some local version of Python, that's fine as well. So what we're going to do today is we're going to pull an outside program. Now this program may seem a little silly at first. It's called Turtle, and it uses turtles to help us visualize on the screen different parts of our program. Now it's very important because it's just like working with any other outside library. So if you're working with another outside library for gathering files from a website or whatever, computer vision or AI or anything else, it's going to follow the same pattern. So I'm going to teach you how you can work with some of those libraries. So the first thing we want to do is do an import statement, and we're going to import that outside library. So what we're going to do is import turtle. Now, very important here, capitalization does matter. So make sure when you're typing along with me that you're following the same capitalization here. Now with Replit, when we do our import like this, it's automatically going to pull in that library. If you're in another environment, you might have to pip install turtle in order to follow along with us. Now we're going to write a couple other lines. So to use turtle, we have to create a window in our program. So we're going to set a variable, and you can call this whatever you want, but if you're going to follow along line for line, you want to call it the same as us. I'm going to follow along with the text, which uses wn. And I'm going to set it equal to turtle.screen. Now I'm using turtle.screen because I'm following along with the documentation, which I'll get to in a minute. So this outside library has a method on it or a function that allows me to create a screen using this exact line here. Now the capitalization obviously matters and blah, blah, blah. Now on that screen, we're going to create an instance of a turtle. So we're going to create an actual turtle object. And we can name this variable whatever we want. In the text, they name it Alex. So we'll follow that. We're going to say Alex equals turtle.turtle. Now again, you'll notice some mistakes I've made already. I forgot an R here. So remember, spelling obviously matters. And then here you'll notice I use a lowercase turtle and then an uppercase turtle. We'll get to a little more of that in a minute, but you want to make sure you're following the exact same format. So what we've done here is we've created a variable that points to our screen, and we've created a variable that points to our turtle instance. Now we're going to do some simple functions with that turtle. We're going to do alex.forward, and we can do 50. And then we're going to have them turn, so we're going to say alex.left, and we'll do 90 to turn 90 degrees. And then we can do another forward of 30, say. Okay. So what we're doing here is we're using an outside library to create two instances of objects. So we're going to create a window object and a turtle object. Now these variables don't matter at all what we call them, the wn or the Alex. They'll work as long as we're consistent and using them throughout. We can call them whatever. The other side, creating our instance, we're using the library's methods and functions and whatever they've built in it. So we have to use the exact spelling and capitalization that they use. So let's go ahead and run this and just see what it looks like. And you can see here it was really quick, but our turtle started, it moved forward 50. It turned 90 degrees left, which makes it go up. and then it moved 30. You'll notice that line's a little shorter. Awesome. So that worked as we expected. So at this point, you're probably saying, all right, that makes some sense to me, but it kind of looks like you're just making this up. How did you know that the function was called forward and not move or something else? Well, this brings me to our first professional tip here. And this is very obvious, and you may think that it's a little cheap that I called this a professional tip, but you need to get into learning to use documentation right away. So if an outside library has a nice documentation page, which Turtle does, you can see that you can pull it up and really look into how exactly it's working here. So if we pull up, and this is on python.org, so Turtle's built into Python itself, so you probably didn't have to do a pip install. But you can see that it has really good documentation here. On the introduction page, and I just Googled this, on the introduction page, you can see it's covering things that we were already doing. We imported Turtle, we moved Turtle forward 15, we turned Turtle right, so on and so forth. They mentioned the Turtle screen class, and then if you keep moving down, you can see it even says Turtle methods. So you can see there's a forward, which we used, a backward, a right, a left, a go to, all these others. Now, some are pretty self-explanatory, right? You could have guessed by using forward, we probably know what backward means. It's probably going to move backwards. But some of these might not make sense to you. So like the speed one. So let's look at speed, and you can see that we can use turtle.speed, and we can have an integer range from 0 to 10 or a speed string, see below. So we can do 0 to 10, 0 being fastest and 10 being fast, and then normal being a 6, slow being a 3, and slowest being a 1. Okay, so that makes some sense. So let's try that. Just off of the documentation, let's try and use the speed function. So before it moves, we remember how fast it moved last time. Let's say alex.speed, and we'll set this to 1. So now if we stop this and run it again, you'll notice that this time it was much slower when it drew it on the screen. So we can add a hash mark in front of it, and that'll comment it out. So now it's not going to run. So let's look at how fast it runs now. And then with that speed, you can see it's much slower. All right, perfect. So that's the first tip that we're going to have here, is using your documentation. All professionals use documentation. It doesn't mean stealing someone else's code. It means referencing how to use other libraries and code. Awesome. So let's do another instance of a turtle. So we have one turtle on the screen right now called Alex. We can actually create another instance of a turtle object. So let's call this instance cat. So we'll set cat equal to turtle.turtle. And this one, let's say cat.color. So let's pass in blue. Now let's do something similar that we did with Alex. So let's say that we move cat. Remember we said we can move backward. Let's say cat.backward. And we can move it back 50. So you'll notice I'm using K-A-T. This is my wife's nickname. So I will use cat like that. So I'm saying cat.color is blue, and then cat backward 50. So hopefully we see a instance of another turtle on the screen, and that it moves backward instead of moving forward. Awesome. So now you'll notice one of the turtles move backwards. You'll notice it's still facing forward, and the other one moved forward the other way. Cool. So now we have two instances of an object, and those are both unique objects. So even though they're both turtles, they're both unique. And you'll notice that we could have called this whatever we want. Instead of cat, we can go back and we can call it Bob. But now we're hanging references here, right? Because now there's no cat turtle instance. So we're going to have to name this Bob and then this Bob. Now if we save and run again, you'll notice it still works. So remember, these variables are changeable. We created them. We can call it whatever. Typically in programming, you want to make as much sense as possible. So I probably wouldn't use name references. I might have called it turtle1 and turtle2 or whatever you're doing with them. But in this example, we're just highlighting that you can use whatever you would like. Cool. So now let's kind of do something neat with both of our turtles. Let's say that we want to make a square with one of them. So with our Alex, we can move forward 50, turn 90 degrees, then we can move forward 50, and then turn 90 degrees. And then we can move forward 50 and turn 90 degrees. So what we're trying to do here is we're trying to make a square with our Alex turtle. We're going to leave cat alone for right now. Let's stop this. We'll run it again. And you'll notice that we've made a square. Now that was really cool. But you might also notice that it's kind of repetitive how we did it. You see how we had to copy these exact 2 lines of code over and over 1, 2, 3, 4 times to make the square. That's where we can use loops to make our programs a little more concise and easy to read and understandable and reusable. So one of the loops that we can use in Python is a for loop. So a for loop is going to execute a certain amount of times. Now, typically when I use a for loop, I know how many times I want it to execute because either I know exactly how many times I want it to run, in this case 4, or I'm having it iterate over a list or something, however many objects there are in that list. So in this case, we can say for I in range, and we can say 4 because we want it to execute 4 times. Now you can see here that there are a couple things that I don't like that I have 8 indents there instead of 4. Let me change that real quick. Change indents to 4. I try to make this just a little bit more readable for you guys when I do these. Okay, that looks good. So you can see here that after we type this line, for I in range 4, colon, you'll notice that it tabs inside. Now, anything inside of this tab is inside of the for loop. You'll notice these other lines are not tabbed inside of the for loop, so they're not part of the for loop right now. So let's do print I, and then we'll talk about what's happening. So if we run this again, our turtle is going to behave exactly the same, but if you look down in our console, you'll see that we printed out 0, 1, 2, and 3. So right here, our for loop is executing 4 times, and each time it's assigning a different value to this I variable. So this I variable is assigned 0 the first time it runs, 1 the second time it runs, 2 the third time it runs, and 3 the fourth time it runs. So in programming, a lot of times our counting starts from 0 instead of 1, which is a little different. But the important thing to note here is this happened 4 times, which is exactly what we needed to do to make a square. So we can actually take 2 of these lines and put them inside of our for loop. So remember, we're going to have to tab them inside of our for loop. And now we can delete these other lines, and we should be able to make our square. So now what's happening? We're no longer using our I variable. So we're going to do nothing with that. Nothing's going to show up in the console because we're not printing it out. What is going to happen is these 2 lines are going to execute 4 times, which, as we know, if we do that, it's going to make a square. So let's stop this. And we'll run it. And you'll notice it makes the square just like we did before. That's really cool, right? Now you can imagine in a project where you're doing something 1,000 times or 2,000 or even 1,000,000 that you can get a lot more advantage than we did from this small improvement, but it's going to be very useful to you. Now, one thing you'll sometimes see, and you'll notice here, is we didn't use I at all in our program, right? So they'll sometimes replace this with an underscore if you're not actually using that variable for anything. So if we run this again, nothing would change. Just something you want to look out for. So what else can we do with a for loop? Well, with a for loop, we can also iterate over things. So say we had a list of names. So we could say names equals, and then do a square brackets. And in here, we could give some different names. We could say Bob. We could do Cat again, Jake, and Bill. Now, if we save this, we can now iterate over this. So instead of using a range here, we can delete that out and we can put in names. So now each time we go through this loop, it's going to do it one time for every value inside of this list. And this time we might want to use it, right? So maybe we create a variable here to hold each name. So this is something that you'll see sometimes, is the plural version being the list and then an individual being the name. So each time we go over this loop now, we can print out the name. And if we run this, our turtle behaves the same. But if we look at our console, you can see that each time it prints out Bob, Cat, Jake, and Bill. Sweet. So that's pretty cool. So it still executed 4 times. Why did it still execute 4 times? Because there's 4 values in our name list. Okay, well, how could that be useful in our program? Let's try and make this a little cooler. And remember, we want it to execute 4 times, so we're going to keep 4 things in our list. Let's call this list colors. In here, we can use colors from the documentation. So we can say blue, green, red, and yellow. Awesome. So now this doesn't exist anymore, so we got to use the new variable, colors. And here we can call this color instead. So now this is still going to execute 4 times, right? 1, 2, 3, 4. And each time we're going to get a variable assigned. So the first run, it's going to be blue. The second, it's going to be green. The third, it's going to be red. And the fourth, it's going to be yellow. Now, each time we do that, let's use that to set our color for our turtle. So the function name is color, and our variable that we're going to use is color. So it should change the color of the turtle every time it goes through the loop. Cool, right? Wow, that yellow is really hard to see, but you can see that now we changed our color each time we went through the loop. So the first one was blue, as we expected, second green, red, and then finally yellow. So you'll see here how we can do some cool things with for loops in general to make our code simpler or more useful. Now, what would happen if I added another color here? Try it and find out. That's another tip here that as we go through this documentation and these programs, don't be afraid to try things out, look at them and experiment a little bit. So if we added another color, we could call it, let's call it black. So now what's going to happen? You might know. So our loop is now going to execute how many times? 5 times, right? 1, 2, 3, 4, 5. And each time it's going to go forward 50, turn 90 degrees, forward 50, turn 90 degrees. So you can see that it's going to go to where it landed before, then turn 90 degrees, and it's probably going to draw a black line over top of our blue line here. Awesome. So it happened as expected. So my next tip is sometimes programs don't have great documentation. So we went to the Turtle documentation page and we saw all of these cool functions and how to use them, and you can experiment and play around here as you go. But what if there isn't a good documentation page? So what I like to do sometimes is print out some data about the class itself that I'm using. If you've watched our other ones, you know that we can do type and then pass in something into this type function. So let's pass in our reference to Alex. So this is going to give the class that Alex is. So if we stop and we run this, you can see it's a class of a turtle. Well, what if I want to know some objects and methods and different things I can do with that specific type? So instead of type here, I'm going to use dir. Now, when I use dir, I'm going to see all the attributes and functions that I can use on a turtle class. Let's run this. Now you'll notice this is way messier than the documentation, but some libraries don't have documentation, so sometimes this is what you got to use. But you can see here that we got a lot of different methods on the turtle itself. And you'll notice that they're the same as on the documentation. It's just a little messier. You can see there's a forward and a bunch of other stuff. Backwards around here, turtle size, all kinds of different things. So that's my second tip, is don't be afraid to print out stuff to the screen and actually take a look at what you're using and how to use it. Awesome. So as I said before, the documentation that we're following is great. I'm not referencing the book Learn Python the Right Way line by line. So if you read that, you're going to get more out of this that I didn't cover and different things like that, and vice versa. So it's a good thing to reference both materials, but they did have an example in there that I wanted to show you because I thought it was cool. So we're going to do that as well. So what I'm going to do here is I'm going to highlight all this, and I'm going to push Control and then slash, and it's the slash underneath your question mark, so the forward slash. So what that's going to do is it's going to comment out all this code so it doesn't run anymore, so it doesn't mess up our new program. You can see nothing happens now, but I also want this to be here if you need it later. So this will be here if you would like to uncomment it. So we're going to use a couple other methods just to show you how a for loop can be kind of cool. So what we're going to do is we're going to create a spiral pattern with our turtle. So you can see up above, we've already declared our turtle. So we got an Alex and a Bob. I'll actually work up here instead so we can see that. Now with the documentation here, we can change the background color of the project itself. So we can say wn.bg color. We can set this to whatever we want. We can set it to blue. It'll just be different than the book itself. And now we're going to do something different. We're going to do alex.penUp. So you'll notice a lot of times when we use functions, we pass things into it. And this one, we didn't pass anything into it. And you'll notice we get a nice little pop-up in Replit from time to time. And if you read this, you can see pen up, it's going to return nothing, and we're not passing anything into it, and it gives us a nice doc string. So it says, pull the pen up, no drawing when moving. Okay, so that we might already kind of know what's going to happen, right? It's not going to draw any line as it moves. So out of curiosity, let's just change that method. Let's control, and then we're going to hit that / again. And you'll see now we have the part that we did before, but now we've pulled our pen up. So if we run this, you'll notice it looks really weird, right? It's not drawing the lines, so it's just moving the turtle. Okay, so that's one of the differences here. I'm going to comment this out again. So we're moving our pen up, so we're not going to draw any lines. And we're going to also create a variable called size. And we're going to set our size equal to 20. And then we're going to use a for loop. So we're going to say for I in range. And here we can decide how many times we want to loop through this. We're going to say 30. So remember, it's going to execute 30 times, but it's going to give us values in a range from 0 to 29. Now, each time we're going to say alex.stamp, another method that you can look up in the documentation, or you can see what it's going to do here. And then we're going to say size equals size plus 3. So each time we're going to increase the amount we're moving here. So they actually use size. I'm going to call this move. So we're going to move 20. We'll set move equal to move plus 3. We're doing the same thing. I'm changing the variable name just because I think it makes more sense to me. And then we can do alex.forward. And now we can pass in how much we want it to move forward. We have a handy dandy variable here. So we're going to say move. And then we can say alex.right. This is how much we want him to turn. And we can turn 24 degrees. So that is a lot here. But we're pulling the pen up. We're setting our original move distance to 20. And then we're executing this loop 30 times. Now, each time, we're increasing our move distance by 3. We're moving forward that amount, and we're turning 24 degrees. So let's take a look at what that looks like. Cool. So you can see here that we're making sort of a spiral pattern from that. We expand it. So now you can see we can kind of play around with this a little bit, right? So if we wanted to try something different, I made my turtle screen too big. I had to refresh here. I got a better setup now. So we could change the values and see how this changes it as well. So one thing that I might want to do is maybe I want to change Alex's color to be white. And I want him to start out moving a little smaller. So we'll start it out at 10. And then maybe every time we only want to increase the move size by 2. Okay, so we can play around with this code a little bit to make it work differently. And you'll see that we got a little different output there. So let's review a little bit of what we did today. So in today's video, we talked about some methods inside of our turtle class. So we used an outside library to begin learning about how to use libraries outside of your current code. And we did that using the turtle library. We also talked about for loops and how they can make our code more concise and do kind of unique things as it goes through the code. So instead of maybe hard coding every single line, we can make our programs more concise and readable by using for loops. Now, if you're following along with this series, I'm going to try and get the next video out quicker. So stick with us here. But until then, make sure that when you're writing this code, you're following along, you're typing the code, and don't be afraid to break stuff. If you're like, wow, why didn't he use I in this for loop for the move value instead of setting a move value each time? Okay, let's delete out that move value and let's use I here instead. And run it. Who cares? Start seeing what things look. That was almost cooler. So don't be afraid to try things out, do things differently. You're not going to break it. And until next time, keep coding.